next term is distance. So let's try to understand these two terms, distance and displacement, simultaneously. Distance. So distance and displacements are two simple terms which we can know very easily. Just try to understand when I am saying that this is y-axis and this is x-axis. Okay, and now I'm saying that there is a point A here and this point A here, and a particle is situated at point A, and the coordinate of this point A is, let's say, xa and ya. Okay, so when I'm saying that that particle moves from A to B in this path, let's say like this. Okay, this path like this. Okay, so now its coordinate becomes xb comma yb. So how we define distance and how we define displacement? So displacement is basically the length of the line joining initial point and the final point. Displacement is the length of the line joining initial point and the final point. This red line is the line joining them. Okay, and the direction of displacement is from initial point to the final point, which will be like this. So I can say this red line represents displacement vector. I am using the letter S for displacement vector. Cool. Now the next one is about distance. So what is distance? Distance is basically the length of the path traversed. So you can see here that this is the path through which the particle has moved, and whatever be its length, use a tape to measure this length, and whatever you get it, that will be the distance of the particle. Okay, fine. So when I say that a particle is moving, okay, I can definitely say that distance keeps changing and distance keeps increasing. Basically, I can bet on it that when the particle keeps moving, the distance of the particle keeps moving, because length of the path traversed keeps increasing, right? But what about displacement? Displacement, when a particle is moving, this displacement can be zero, can be something positive, something negative, because displacement is a vector quantity and it depends on initial and final point. Okay, I'm not using the word shortest distance, because sometimes if I'm saying that sometimes shortest word can be confusing one. So if you are clear about shortest distance, means the shortest in term of the length of the path, then cool, it is okay that this is shortest distance. But if you are saying that shortest in term of time travel, time taken by the particle to reach from point A to point B, then that will be confusing. There can be situations in which I can say that the length of the path is the smaller one, but the time is the larger one. For example, if we use such type of trajectories like this, one trajectory is nothing but a straight line, an inclined plane. This is what, and the another one is this. Okay, so kind of curved. Now you have to take two balls and put one balls on this trajectory, another on this trajectory, and you will see that this ball will take less time if this one is t1, and if this one is t2 time, and t1 will be less than t2. But here you can see that you can see that basically this one the path in which t2 time is taken is basically the path which is the shortest one, right, which is the shortest one. Okay, but still the time is the larger one. This can be seen by an experiment, and you can do by yourself also to see this. The what about what is the reason behind it, we will try to understand in mechanics section. Okay, so that's why I'm not saying shortest path. So if you want to say shortest path, then you must mention that shortest in term of length, then okay, in term of length, not in term of time. Cool. So this is distance and displacement. Another thing, if we analyze mathematically what is distance and what is displacements, so let's try to analyze. I am saying that for a very small amount of time interval, let's say dt time interval, for a very small amount of time interval, let's say dt time interval, if the particle is moving like this, like this, like this, like this, very very small dt time, it is smaller than your imagination, okay, like this, then I will say that means first dt time it traveled a length of dr1, then dr2, then dr3, and so on, like this, dr3, then dr4, and so on. Okay, so if I'm saying that displacement s vector will be defined as integration of dr vector, this is cool, no problem. If you use vector and a vector as a tool to solve this problem, integration of dr, with the help of polygon law I can say dr1 vector plus dr2 vector plus dr3 vector and so on will give you the resultant, and the resultant will be s vector. So no problem in saying this. So it is integration of dr vector. Okay, but what about what about distance? If you want to find out distance with the help of integration, you have to do integration but magnitude of dr. Okay, magnitude of dr integration will give you distance but not displacement. So be aware about this, and don't get confused. We have the integration of dr vector in the first case, and we have the integration of magnitude of dr vector in the second case. Okay, fine. So let's try to do some questions about distance and displacement. Let's figure out. First question. So the very first question is this. We have a particle starts from point 1 and along the curved track it reaches point 2. What is the distance and the displacement which you have to find out? So I will say distance is simply what? It is the length of the track, which is, you know, if it is a circle, then a semicircle's length will be simply pi r. Okay, what about displacement? So displacement will be simply equals to the length of the line joining of initial and final point, which will be this. You can see here this, and the direction will be in this way, initial to final. So I will say its magnitude is 2r and its direction is from 1 to 2. Now moving to the next question. Again the particle starts from here, point 1 to point 2, and it reaches. You have to find out distance and displacement. You may pause the video and solve the question. Okay, so let's try to solve it. First, for getting the distance, you have to get the arc length, and it will be given by theta equals to L by r, well, where L is the length of the arc and r is the radius, and theta must be in radian. So I can say here the theta is in degree. I must convert it into radian first, so it will be pi by 3, and radius is r. So this is L, and which is equal to distance. Okay, and what about displacement? Join initial and final point. Look at this. This is your s vector, and you can see that you have to calculate the length of this line joining. If this one is r, this one is also r, it is 60 degree, and it must be an equilateral triangle. Okay, this is also 60 degree, this is also 60 degree, so you can clearly say that this s vector is also equals to r. So displacement is equals to r, and its direction is from initial to final. Let's move to the next question. The question is, we have a disk and it is rotating, as well as basically performing a rolling motion, rotating as well as moving ahead, right? And without any kind of slipping. Okay, so this particular disk is keeps on moving. So you have been asked that if this yellow point is highlighted on the disk, what will be the displacement of this particular yellow point when it covers half of the full rotation, or you can say half of the rotation, half of the complete rotation, right? So what will be the displacement of the yellow particle when this disk complete half of the yellow half of the rotation? Okay, so let's try to solve it. Okay, So when I will say that in full rotation, this yellow point come back to this bottommost area, bottommost point. Okay, so in half of the rotation, this yellow point must reach the top of the disk. Okay, so I must say that if you want to calculate displacement, you have to join initial and final point. So this is that line, this is that line. Okay, this is that line, this is that line. Okay, you have to calculate it. So I will say that this is base and this is perpendicular, and the perpendicular is 2r basically, right? And base is basically, since it is half of the rotation, I must say in full rotation its center covers 2 pi r. In full rotation its centers cover 2 pi r. So in half rotation its center will cover pi r. Okay, so if the center is covering pi r, so it must be pi r. Okay, fine. So I must say that using Pythagoras theorem, displacement is coming to be 2r whole square plus ir whole square, then root over. Okay, this is the answer. May check it. Okay, thereafter I'm not asking about the distance, because distance will be little difficult one, which will be dealt in the rotational motion. Okay, now the next question. What is the question? Particle starts moving first in the north direction, and it covers 6 meter, and then in the east direction and it covers 8 meter, and then in the vertical direction and it covers 10 meter. First of all, you have to calculate distance and displacement both, and you must understand while solving this question that north, south, east, west is a case of horizontal plane. This is north, this is south, this is east, this is west, all lying in a horizontal plane, and vertical plane none of them will lie. Okay, so the question is, particle starts moving along the north with 6 meter, and then turns towards east with 8 meter, and then move vertically upward with 10 meter. What is the distance and displacements? Okay, so let's find out distance first. So it covers simply 6 plus 8 plus 10, and that's it. So it is coming to be 14 plus 10, which is 24 meter. Okay, and what about displacement? So for displacement, let's draw a cuboid first. To have a visualization of the question. Then I will say that particle move north like this, and then east like this, and then vertically upward like this. So this is the trajectory of the particle followed. Okay, so to get the displacement, we have to join it. We have to join the initial and the final point. Which you can see it is a body diagonal. So to get the length of the body diagonal is simply root of a square plus b square plus c square, which is 6 square plus 8 square plus 10 square, which is coming to be 10 root 2, which is 200, right? So that is why it is 10 root 2. So this is the displacement. Coming to the next question, a very good question asked in SAT exam. Okay, so what's the question? We have a fixed circular track of radius 3r, and we have another coin, you can say, or a disc rolling on this circular track. Fine, and this circular track has a radius of 3r, which is fixed, and the coin is having radius r. Okay, so you have to calculate, while completing the revolution, how many rotations will be done. So revolution and rotation are two different terms. You are very well aware of that. Okay, so I am asking here that how many rotations will be done by the coin in one revolution. How many rotations will be done by the coin in one revolution? Let's calculate it. Okay, so as I told you that center covers a distance of 2 pi r. Okay, when it completes one rotation. Okay, so I'm saying, okay, let's draw a circle first, like this. So if I'm talking about this particular radius, okay, this particular green circle, what is the length of this green circle? Okay, so I will say the length of the green circle is 2 pi into 4r, 3r plus r. Okay, and if I'm asking how many in one rotation, what is the length covered by the center of this coin in one complete rotation, what is the length which will be covered by the center of this coin, and that will be something like this, let's say like this, okay, and that will be simply equals to 2 pi into the radius of this coin. So in one rotation, center will cover 2 pi into radius of the coin, okay. So this is in one rotation, and this one is the total length which has to be covered by the center. So I must say the number of rotation in completing the full revolution will be equals to 2 pi into 4r upon 2 pi into r, which is coming to be 4. So this is the answer. Okay, so that's it for today. I will back with some more important terms and topics. Thank you.